Hello, my name is Gary Halada. I'm a professor in the Department of Materials Science and Chemical Engineering. I'm also the undergraduate program director for the Engineering Science program. I'd just like to tell you a little bit about my background, about the program, and why this would be a great program for you to get involved in. My research, being from the Department of Materials Science and Chemical Engineering, is in materials, is in the surfaces of materials in particular, especially how they interact with the environment. And that can include a lot of different things, and that are very important for purposes of energy or environmental applications. I'm interested in how surfaces are tailored or engineered at the nanoscale to perform in certain ways. For example, to be more corrosion resistant or to be able to break down environmental pollutants. I like to apply my expertise to various areas, including, well, I've been involved in everything from looking at nuclear waste and decontamination of structures to recycling of clothing to latest developments in the 3D printing of metals. I like to study also how to improve engineering education. So I have a good amount of pedagogical research I'm involved in. Everything from looking at civic engagement for students to how science fiction and narrative can be used to enhance engineering education. And that can be both reading and writing science fiction as a way to think about ethics, for example. The courses I teach include ESG 100, which is the Introduction to Engineering Science and Design. Also, several of the courses in the Nanotechnology Studies program, the introductory course, ESM 213 and ESM 400. That's a minor that I started with support from the National Science Foundation to look at nanotechnology from a number of different perspectives. I also teach a large course, ESG 201, entitled Learning from Engineering Disaster. And that course is part of the Stony Brook curriculum, which means I teach it for a lot of different majors, but it's very important to the engineering science program as well, since we used engineering disasters and how engineers learn from those disasters and failures to make better designs as a way to learn about not just engineering, but also ethics and failure analysis and risk, for example, a lot of important issues. I also co-teach a course in the Honors College, first-year course, Honors 105, which is Modes of Knowledge. I co-teach that with some faculty from the humanities. So I'm interested in a lot of different both areas of research having to do with materials, but also how to improve engineering education and how to look at the integration of the liberal arts into the engineering education, for example. So these are a few of the areas that I like to look at. Anyway, how I got here is I was an undergraduate at Stony Brook. I studied physics with a minor in technology and society. And then I became a graduate student in material science and engineering, and the rest is history. I'm still here. So I'm very well acquainted with the university and with programs here. I mentioned I am the undergraduate program director for engineering science. And so let's talk about what engineering science is. It's engineering and science, naturally, but I think of it as really a course of study that looks into how to apply the methods of science, testing of hypotheses, scientific tools, for example, how that's applied to engineering needs, to making improvements in designs or improvements in materials. I think it's important to learn about all areas of engineering, but especially within engineering science, we look at how physical sciences, engineering sciences like material science and thermodynamics, fluid dynamics, as well as modern laboratory practice and programming can be used to better understand the engineered world and how to solve problems. And all types of problems, from materials for extreme environments, including, for example, inside the human body or inside a nuclear reactor. Also looking at how to make better photovoltaics, the materials, other technology involved, challenges of climate change, specifically how climate change, for example, impacts infrastructure and what can be done to build better so that future climate issues are less likely to cause a catastrophe. Designing semiconductor devices for faster computers. All these are different areas where engineering science can play an extremely important role. So although it seems like a general engineering major to some degree, you do get more specialized knowledge, especially in a range of emerging technologies, and that can be very valuable. There's a number of unique aspects to the engineering science program. One is its flexibility. As I mentioned, we have a number of specializations. We have a number of opportunities to take technical electives from departments across the campus. And through those courses, you can learn more about a lot of different areas. And we work together to try to select the best courses that meet your interests and your career plans, what areas that you think you would like to understand more about. Our department also has a very high level of research activity and research support. In fact, our faculty have possibly the highest per capita research spending and activity on campus and within engineering, or at least one of the highest, if not the highest. So we're very invested in cutting edge research. And that's very important for the undergraduate program as well, because you can become involved in some of these research projects. So what does it mean? What's most important for successful to be a successful engineering science student? Well, our most successful students are motivated and engaged, and they do take advantage of these opportunities for research or involvement in other aspects of our program. We involve undergraduates in our committees and in our, as I said, in our research in our laboratories. And I think this is a extremely important part of what kind of experience you can have when you're at the university. I've often thought about it. A university education isn't just what you learn in a lecture in a classroom. It has to do with how you're involved on campus, your clubs and activities. It could be sports. It could be any of a number of things. And for an engineering student, I think it's very important, especially in engineering science, to be involved in some of the leading edge engineering activities on campus and with some of our great faculty. Our students, through this process, gain a great deal of self-efficacy. And by that, I don't just mean a belief in oneself, but a belief in your ability to find the information that you need to solve a problem. Because engineering is problem solving. And it's very important that you're able to understand that you can go out and find the information, find the expertise, find the equipment, or at least know where to start looking in order to solve problems. And that's very important for any career you might follow in industry or any of a number of different types of careers. Our graduates, they don't go on to graduate studies, but many of them do, have the right skills for areas such as project management, pre-med, pre-law programs, failure analysis, quality assurance, testing, manufacturing, a lot of areas where a broader engineering background is very useful, but especially where a multidisciplinary type background is useful. Our students understand, our graduates understand not just different aspects of engineering science, but also the language of the different areas of engineering, and can see where multiple areas can be brought together to solve an important problem. As I mentioned before, we have specializations. Now, these specializations are great for giving you some focused knowledge in a particular area. Some of the specializations sound like majors. I mean, we have a manufacturing and mechanical engineering specialization, which is different than the mechanical engineering major. We have an electronics engineering specialization, which is different than the electrical engineering major. The majors obviously give you more intense, more structured and extensive knowledge in a particular area, which is great for certain occupations or graduate programs. So specializations just give you some depth of focus in an area, but mainly in how you would apply the knowledge from other from the background you receive in engineering science to one of these specialized areas. We have an environmental engineering specialization, for example, and that differs a bit from the civil engineering environmental program, but specifically in how you can apply material science to environmental problems, development of recycling technologies, remediation methods, as I mentioned before. These are material science and engineering approaches to environmental problems. So you can see how this type of major can really help you to develop a broader perspective, but also specialized knowledge that you can apply to an area that you're interested in. I mentioned before that this is very useful if you, not just if you go into a certain engineering field, but if you want to pursue graduate studies, you can go into graduate studies in materials engineering or other areas, including, our students have gone on to graduate programs at many leading universities, and including at Stony Brook itself, like myself. So you can also pursue a 5-year program, which is a bachelor's degree in engineering science, and with an additional year of study, you have a master's degree in material science and engineering. And quite a few of our students take advantage of that opportunity as well. So last but not least, was asked what one piece of advice I would give for an incoming student to prepare for their first semester in the ESG program. Pretty much what I've said already. You have to explore the curriculum and the people here to make the most of your time. So you have, for example, you wouldn't move to a town that you had no idea, you were unfamiliar with without finding out a little bit about it. Maybe Googling, where the best restaurants are or something, anything. So the same way when you go into a new program or you go into engineering science, I would strongly advise you to become very, very familiar with it. Look at all the courses. Look at some of the textbooks, the websites of the courses. Look at the individual faculty members' websites. Look at the department website. You'll get a good idea for what sort of things are going on that would really help you. Things that you could become involved in, as I've said. And most importantly, please feel free to reach out to our faculty and staff with your questions. I'd be happy to have a chat with you if you're interested via Zoom or a phone call. And I can let you know more about what we offer and basically how you can start to, if you're an ESG student, how you can start to build a career around what you do here. Well, more than a career, really how you can build start to build a life of leadership and engagement in solving meaningful problems during your experience at Stony Brook. So that being said, I welcome you to our program, and all I can say now is just see you soon and look forward to talking to you.